there's a 40% chance that 3I-ATLAS, that it's alien technology.
So far, it could go down to 0 or 100% once we get more data.
An interstellar visitor, 3I-ATLAS, bigger than Manhattan, is racing through our solar system at 130,000 miles per hour. On October 29, 2025, it makes its closest pass to the Sun. NASA calls it a comet. But Harvard's Avi Loeb argues its path and behavior raise a harder question. Could 3I-ATLAS be something designed? Let's find out. Signs of something more. In July 2025, a new interstellar visitor appeared. An object so big, so fast, and so unusual that it instantly divided the scientific world. Because 3I-ATLAS isn't acting like a normal comet should. One night it looks ordinary. The next it's glowing green, brighter than anyone expected. Its orbit doesn't wander the way comets usually do. Instead, it follows a path so precise, some call it too perfect to be a coincidence. Then there's its chemistry. Astronomers peering through the world's largest telescopes are finding strange signals buried in its light. Things they never expected to see from a frozen object. Some even claim it carries the fingerprints of metals that shouldn't be vaporizing at all. And if that wasn't enough, an even stranger whisper entered the conversation. The infamous WOW signal. A mysterious burst of radio waves was picked up in 1977, never repeated, never explained. Some researchers now wonder if that decades-old signal could somehow be connected to this very same object. Add all this together, and you get a picture that doesn't sit comfortably in any category. On the surface, it looks like a comet. But the deeper you look, the more the puzzle pieces refuse to fit. Is it natural? Is it artificial? Or is it something in between that we haven't even imagined yet? And here's the part that makes astronomers restless. 3I-ATLAS is on a countdown. On October, it will swing closest to the Sun, hidden from Earth by the Sun's glare. It's the most important moment, the one that could reveal everything. That will happen when no one on Earth can watch. So we're left with hints. Coincidence? Maybe. A cosmic accident? Possibly. Or could it be something else entirely? That's the mystery of 3I-ATLAS. And in the next chapters, we'll pull apart the clues, one by one, to see if this really is just another comet, or something much stranger. NASA's safe answer: just a comet. Ask NASA about 3I-ATLAS, and you'll hear a simple answer. It's a comet. Nothing more, nothing less. A frozen ball of gas, dust, and rock drifting in from interstellar space. To the agencies and observatories tracking it, the story is straightforward. Comets, after all, are familiar territory. We've been watching them for centuries. They form in the icy outskirts of planetary systems, and when they pass close to a star, they start to heat up. Gas and dust vent into space, creating that glowing coma and tail we all recognize. It's a routine process, and from a distance, 3I-ATLAS checks the right boxes. NASA emphasizes that, despite its size, it poses no threat to Earth. The closest it will ever come is about 150 million miles away, 1.5 times the Earth-Sun distance. In other words, no collision course, no disaster movie ending. To most astronomers, it's an extraordinary opportunity for science, not a danger. They also point out that interstellar objects aren't brand new anymore. Oumuamua came first in 2017, then Borisov in 2019, now 3I-ATLAS in 2025. Each one reminded us that our solar system isn't isolated. It gets visitors. NASA's line is that this is simply the largest one we've caught so far. Nothing more exotic than that. And officially, that's where the story ends. A giant comet, dazzling to watch, historic in its size and speed, but still a comet. NASA and ESA are preparing telescopes, spacecraft, and observatories to study it in detail as it makes its pass. They want to learn what it's made of, how it behaves, and what it can teach us about other star systems. But here's where things get interesting. Outside of the official press releases, astronomers whisper about the parts that don't quite fit. Why is it so massive compared to any other interstellar visitor we've ever seen? Why does its orbit line up so neatly with the planets? And why do some of its features look different? NASA sticks to the safe explanation. This is nature at work, nothing more. But the puzzle is bigger than that. And if you're willing to step outside the official narrative, you start to see why scientists like Avi Loeb are asking harder questions, heavier than it should be. Every comet we've ever studied behaves a little like a leaking rocket. As sunlight warms its surface, jets of gas shoot outward, creating those familiar tails. And with every jet, the comet's orbit wobbles just a bit. It's subtle, but measurable. And it's part of how scientists confirm that what they're tracking really is a comet. But 3I-ATLAS, it barely moves. This object is venting massive amounts of material, carbon dioxide, dust, and water vapor. Yet its orbit stays almost perfectly locked to gravity. It's like a freight train thundering through space, unstoppable, steady, unaffected by the forces that usually nudge a comet off course. The numbers tell the same story. Astronomers estimate its core to be at least 12 miles across. That's longer than Manhattan Island stretched end to end. And the mass? A staggering 33 billion tons. To make that easier to picture, the asteroid that wiped out the dinosaurs was only about 7 miles wide. 3I-ATLAS could be nearly twice as large. If that impact reshaped life on Earth, imagine the scale of an object even bigger barreling through space. And here's the fact. Based on what we know about how interstellar objects form, we should rarely see one like this. Avi Loeb calculated that a rock this size should only pass through the inner solar system about once every 10,000 years. Yet, we've only been running systematic sky surveys for a single decade. And here it is already. The odds of that happening by pure chance? Astronomically low. So, we're left with two possibilities. Either we got incredibly lucky, like buying one lottery ticket and winning on the first try, or 3I-ATLAS isn't here by chance at all. Maybe its appearance is intentional. Maybe it was steered. And that's what keeps scientists awake. Because when something this massive behaves like no comet we've ever known, huge, steady, immune to the nudges of outgassing, the safe explanation of "it's just another comet" suddenly doesn't feel so safe anymore. This weight problem isn't just about numbers. It's about odds, about physics, and about whether we're looking at a natural wanderer or the first sign of something designed, the impossible path. If the sheer weight of 3I-ATLAS raises eyebrows, its path through space makes jaws drop. Most interstellar visitors come in at steep, chaotic angles, like stones skipping across a pond. They slice through the solar system once, vanish into the dark, and rarely line up neatly with anything. But 3I-ATLAS? It's playing by a different script. This object's orbit lies almost perfectly in the same plane where the planets circle the sun. Not tilted wildly, not random, but aligned within just 5 degrees of the solar system's flat disk. That might sound small, but in the architecture of space, it's razor thin. Imagine tossing a dart from one skyscraper rooftop to another and hitting a crack in the sidewalk below. That's how precise this orbit looks. Because of that alignment, 3I-ATLAS doesn't just drift harmlessly by. Instead, it threads the needle through planetary orbits, swinging unusually close to Mars, Venus, and even Jupiter. The statistical chance of that happening naturally is breathtakingly low. Avi Loeb and his team put the odds at about 1 in 20,000. To put that in everyday terms, that's like picking the winning number on a roulette wheel 6 times in a row, or guessing the same coin toss correctly 14 times back to back. In other words, possible. but so rare it stretches belief. Then there's the matter of timing. In October, when 3I-ATLAS reaches its closest point to the Sun, Earth will be positioned on the exact opposite side. Our telescopes, blinded by the Sun's glare. The moment astronomers most want to see, the critical pass when any unusual activity could be revealed, will unfold in total invisibility. To the cautious scientist, this is cosmic bad luck. To others, it feels uncomfortably like a strategy. If you wanted to hide a maneuver, maybe using the Sun's gravity for a slingshot, or altering your course when no one can watch, this would be the perfect moment to do it. Even more unsettling, the object's approach direction adds another layer of intrigue. 3I-ATLAS is coming from the dense, star-rich region of the Milky Way's center. Billions of suns, countless planets, and endless possibilities. Of all the places it could have originated, it comes from the busiest patch of our galaxy. Again, coincidence or something more? So we're left with a picture that doesn't behave like chance. A giant body, improbably aligned, arriving on the perfect angle from the busiest direction and crossing the Sun exactly when Earth can't watch. That isn't the profile of a routine comet. That's the profile of something we may not yet understand. The blackout window. Astronomy thrives on light. Every comet, planet, or galaxy we've ever studied is revealed by the photons that reach our telescopes. But for 3I-ATLAS, the most critical phase of its journey happens at the one place in the solar system where light becomes the enemy, directly behind the Sun. On October 29, 2025, the interstellar giant makes its closest pass to our star. Astronomers call this point perihelion, the moment when a comet usually flares brightest and reveals its true nature. But not this time. When 3I-ATLAS hits perihelion, Earth will be on the far side of the Sun. No spacecraft anywhere near Earth will be able to separate the object's faint glow from the blinding furnace of the Sun itself. This period is known as a solar conjunction blackout. Entire spacecraft operations are often paused when Earth and the Sun line up this way because radio signals can't get through the solar interference. In other words, the exact moment 3I-ATLAS will be most active is the exact moment when our instruments are effectively useless. Now, if you believe it's just a natural comet, this is nothing more than bad timing. But if you believe, or even suspect, it might be something more, the blackout window looks suspiciously like the perfect cover. Think about it. If an object wanted to adjust its course, release probes, or even alter its trajectory in a way that would otherwise raise alarms, it could do so while hidden in plain sight, cloaked by the Sun's brilliance. And when the object re-emerges weeks later, after early December, we'll have no continuous record of what happened in the shadows. We'll only see the after picture. Did it change direction? Did it accelerate? Or will it look unchanged, leaving us to wonder whether we simply missed the biggest moment in astronomical history? To make matters stranger, blackouts like this don't happen often. They're a product of geometry, Earth, Sun, and a passing object forming a perfect line. For 3I-ATLAS to arrive at perihelion right in the middle of such a conjunction is, again, either pure cosmic accident or something that feels deliberately timed. Astronomers are scrambling to find workarounds. NASA is coordinating with spacecraft at Mars and Jupiter that might get a sidelong glimpse. But even those views will be limited. For all practical purposes, October 29th will be a blind spot. And that's what makes this chapter of the story so unsettling. At the exact moment when we might finally learn whether 3I-ATLAS is a comet or something engineered, the universe, or perhaps the object itself, pulls a curtain across the stage. By the time it comes out, we may be looking at the same comet, or something that's changed forever. Chemistry that doesn't belong. If size and trajectory weren't enough, 3I-ATLAS also comes with a chemistry set that refuses to behave. Astronomers expected a typical mix of ices, water, carbon monoxide, maybe some methane, the usual recipe for comets. Instead, they got something stranger. First came the glow, not just the usual dusty haze, but a brilliant green tint that flashed across telescope images as it drew closer to the sun. Comets can glow green, but Atlas flared brighter than anything expected, almost like it switched on a light. Then came the spectroscopy, the fingerprints of what the comet is actually made of. Using the Hubble and James Webb telescopes, astronomers detected an unusual chemical balance. Roughly 87% of its outgassing is carbon dioxide, 9% is carbon monoxide, and only about 4% is water vapor. For context, most comets in our own solar system are water-rich, with CO2 and CO playing secondary roles. Here, it's the reverse. It's like finding a recipe where the ingredients are flipped upside down. But the strangest discovery came from the European Southern Observatory's Very Large Telescope in Chile. Using its UVES spectrograph, researchers spotted nickel atoms streaming out of the comet's coma. That alone was surprising. Nickel is a heavy element, the kind you expect locked inside rock, not freely vaporizing in space. Even more puzzling, nickel was present in high amounts while iron was nearly absent. In normal comets, the ratio of nickel to iron is fairly stable. In 3I-ATLAS, it's skewed wildly out of balance. Why is that strange? Because at the distances 3I-ATLAS was observed, it should be far too cold to release metals like nickel at all. The surface temperature wasn't high enough to vaporize the minerals that hold these atoms. Yet, somehow, nickel was floating in the gas cloud, without the expected companion of iron. That breaks the rules of comet chemistry as we know it. Echoes of the WOW signal. In August 1977, a strange signal from deep space hit the Big Ear radio telescope in Ohio. It lasted 72 seconds, was incredibly strong, and came from the constellation Sagittarius. The astronomer on duty, Jerry Eman, circled the data printout and scribbled a single word in red pen. Wow. For decades, the WOW signal has been a legend in astronomy, the best candidate we've ever had for a possible message from beyond. But it was never repeated. No one knew if it was interference, a natural burst, or something much stranger. The trail went cold. Until now. Fast forward almost 50 years, and Avi Loeb noticed something that others had overlooked. In 1977, when the WOW signal was detected, 3I-ATLAS was in that same region of the sky. At the time, it was still incredibly far away, about 600 astronomical units from Earth, or more than 55 billion miles out. Practically invisible. But the alignment is uncanny. The signal came from Sagittarius, and 3I-ATLAS was in Sagittarius. The odds of that being random? Loeb calculated them at 0.6%. If the signal did come from 3I-ATLAS, the implications are wild. To be detected across that distance, the source would have needed a transmitter outputting at least half a gigawatt to 2 gigawatts of power. That's about the output of a large nuclear reactor on Earth. Not impossible, but far beyond what nature produces at random. Even more intriguing, the signal showed a slight blue shift, meaning its frequency was shifted upward as if the source was moving toward us. The velocity implied by that shift? About 20 to 40 miles per second, the same ballpark as the speed of 3I-ATLAS on its current journey. Skeptics argue it's just a coincidence. Space is full of background noise, and 3I-ATLAS wasn't even discovered until decades later. But for others, the connection is too tempting to ignore. What if the WOW, the signal, wasn't random at all? What if it were the first faint hello from an interstellar visitor, announcing itself long before we could see it? And now, that same visitor has finally arrived. Bigger than Manhattan, faster than anything we've seen, and loaded with mysteries. Whether it's a coincidence or not, the possibility that the WOW signal and 3I-ATLAS are linked turning the story from strange to extraordinary. Because if those 72 seconds in 1977 really were a message, then 3I-ATLAS isn't just a comet crossing our skies. It's a return. Trojan horse or mothership? At what point does a comet stop looking like a comet? For Avi Loeb, that question isn't rhetorical. He believes we should at least entertain the possibility that 3I-ATLAS isn't just a frozen rock, but something far more sophisticated, maybe even a kind of Trojan horse. The idea isn't new. Science fiction has played with it for decades. An object that looks natural from a distance but hides an engineered core, silently drifting until it arrives at its destination. What makes 3I-ATLAS suspicious to some is that it already checks a few of those unsettling boxes. Think about it. We have an object the size of Manhattan, racing at 130,000 miles per hour, arriving at an orbit aligned with the planets, and doing so in a way that defies the odds of random chance. It passes close enough to Venus, Mars, and Jupiter to get a sweeping look at the inner solar system, almost as if it's conducting reconnaissance. And then, at perihelion, it disappears behind the sun, the exact moment no one on Earth can monitor its behavior. That's the perfect scenario if you wanted to mask an operation. Imagine 3I-ATLAS releasing smaller craft, mini-probes, while hidden from our view. Loeb and his colleagues have even speculated about this. The idea of a larger interstellar ship functioning as a mothership, dropping off smaller devices as it swings past. From a strategic point of view, it makes chilling sense. To frame the discussion, Loeb introduced what he calls the Loeb scale, a ranking from 0 to 10. At 0, you have a completely natural object, like a textbook comet with a tail and nothing unusual. At 10, you have unmistakable technology, maneuvers, lights, radio transmissions, or artificial heat signatures. Where does 3I-ATLAS sit? Loeb argues it isn't at 0. Its chemistry, its trajectory, its stability, all push it higher up the scale. Not proof of alien technology, but enough to demand a closer look. Critics call this science fiction, but Loeb counters with a simple point. If an intelligent civilization existed for even 1,000,000 years longer than ours, their technology could be beyond our imagination. To them, disguising a probe as a comet might be trivial. To us, it would look like an ordinary chunk of ice, until we notice the cracks in the disguise. So here's the unsettling possibility. 3I-ATLAS may not just be passing through. It may be watching, studying, or even preparing. A mothership hidden in plain sight. Clash of minds. Whenever a strange object crosses our skies, two camps form. On one side are the skeptics, the voices of mainstream science, who argue that extraordinary claims require extraordinary evidence. On the other side are the believers, or at least the open-minded skeptics, who say ignoring anomalies is just as dangerous as overhyping them. With 3I-ATLAS, the divide has never been sharper. NASA, ESA, and most astronomers stick to the safe line. This is a comet, just a bigger and faster version of what we've seen before. They point to its coma, that cloud of gas and dust, and argue that the chemistry, while unusual, doesn't prove anything artificial. They remind the public that comets are messy, unpredictable bodies. Some outgas violently, some fracture, some flare green. Odd behavior, they say, doesn't equal alien technology. But Avi Loeb and a handful of colleagues refuse to let the oddities slide. They aren't claiming 3I-ATLAS is a mothership. What they're saying is simpler. Don't dismiss the possibility. Loeb argues that for too long, astronomy has been guilty of playing it safe, forcing anomalies into existing boxes rather than admitting when something doesn't fit. Oumuamua in 2017, he says, was a perfect example. Its odd shape, lack of tail, and unexplained acceleration sparked wild theories, but the mainstream community rushed to shut them down. Years later, we still don't know exactly what it was. The skeptics counter with their strongest point. So far, there is no direct evidence of technology. No lights, no signals, no maneuvers. Without those, calling 3I-ATLAS artificial is, in their view, premature at best and reckless at worst. If every strange comet is labeled alien craft, real science gets buried under hype. Yet the believers fire back with a question of their own. What if playing it safe makes us miss the truth? What if the first real sign of extraterrestrial intelligence doesn't look like a flashy spaceship at all, but exactly like this? A massive, stable object disguised as ordinary rock and ice? The debate isn't just about one comet. It's about how science should handle the unknown. Should we treat anomalies as errors until proven otherwise, or as opportunities to test bold new ideas? 3I-ATLAS forces that tension into the spotlight, and while the two sides argue, the clock keeps ticking toward October 29th, 2025. Skeptics call it a comet. Believers see a Trojan horse. The truth? It's still hidden behind the glare of the sun, humanity's blind spot. For all our telescopes, satellites, and space probes, humanity is still flying blind in many ways. A century ago, we couldn't even imagine interstellar visitors. A decade ago, we had never seen one. And now, in just a few short years, we've tracked 3, culminating in the most puzzling of them all, 3I-ATLAS. Whether you believe it's a comet or something more, one truth stands out: we aren't ready. If this were natural, it would still rewrite what we thought we knew about interstellar debris. If it's artificial, it could be the first real encounter with technology not of this Earth. Either way, the stakes are enormous, and our preparedness is thin. Astronomers like Loeb argue that we need a global plan. We have protocols for asteroids, climate disasters, and even nuclear threats. But what about alien tech? What about the possibility that an interstellar object isn't random but intentional? Right now, no international organization is tasked with answering those questions. It's a blind spot, one that 3I-ATLAS has forced into focus. If we dismiss it as just a comet, we risk ignoring warning signs. If we leap too fast to alien mothership, we risk losing credibility. Either extreme leaves us vulnerable. The real challenge is holding both ideas at once. Open-minded enough to ask what if, but disciplined enough to demand evidence. And here's the uncomfortable part. The universe doesn't wait for us to make up our minds. 3I-ATLAS is on its way, hurtling toward perihelion on October 29, 2025. By the time it emerges from behind the sun, we'll either see the same object continuing on its path, or something that has changed in ways we can't yet imagine. If history has taught us anything, it's that the cosmos loves to surprise us. The asteroid that ended the dinosaurs. The black holes we never believed existed until Einstein's equations proved them right. Even the discovery of planets orbiting other stars, once considered science fiction, is now routine. The universe keeps pulling back the curtain, daring us to look deeper. 3I-ATLAS may turn out to be a natural wonder, a frozen relic from another star system, offering secrets about how alien worlds form. Or in the smallest but most daring corner of possibility, it may prove to be a visitor with purpose. Either way, one thing is clear. Humanity is standing at the edge of discovery, staring at a question mark racing through the sky. And until we face our blind spot, the biggest mystery may not be what 3I-ATLAS is, but whether we're ready to find out. Could this be nature at work, or are we seeing a clue of something greater? Let us know in the comments, and remember to like, share, and subscribe for more mysteries from the cosmos.